Okay, so today I want to solve for the fourth root of 16. And what I want to do is I want to relate this inside value to this expression. And then I want to just try to manipulate it to get it back to the entire expression. So we can kind of realize that this is going to be on the real axis. And we can realize that by just saying, if we take the inside, 16, 16 is a real number, no complex component, and we can just write that here. So we'll say this is 16, this point is 16, that's on the real axis, and we have the imaginary axis. And then we can kind of write this as this. And we kind of see that if we do that, we're going to get r is equal to 16, right, because it's 16 away. And then we're going to get theta. Well, theta can be any integer multiple of 2 pi. So if we have, let's say, some initial theta, we can choose whatever we want it to be. I'm going to pick 2 pi, but you can pick whatever you want. We can do plus 2 pi k. And we see right now that this is kind of going to be a constant, and this is going to vary. And we should get 4 values. That's kind of an indicator that this k value is kind of important. So now we're going to say that if we take the fourth power of this expression, we can set it equal to this, right? And let's kind of relate that back. So let's do that first. So we can now say that 16 e to the I theta naught plus 2 pi k. So now we can relate this expression back to this because this is the same, right? We're always going to get, because our theta naught can be 0 to pi, it doesn't really matter, but we're always going to get back to this point, right? Because if we expand this out, we're going to get this, we're going to get the imaginary part is 0. Anyways, let us now take the fourth power. Let's set these equal to each other, right? Let's say that, and take the fourth power. So we're going to take, basically, this expression is going to be in blue. Take 4 square root 16 applied to the fourth power is going to be equal to, this in green, 16 e to the I theta naught plus 2 pi k. And we see that k, I'll write it again, where k is 0, 1, 2, 3, dot, dot, dot. This is generally, in this case, we'll have 4 values, so these will be our 4 values, right? If you had 5, you get 1, 2, 3, 4, right? If you had 6, you get 1, 2, 3, 4, 5. You should get as many values as this power, because we should get that many values, and we see that in this case, our r is constant and our theta is changing. So that's where we're going to get our different values from. So again, now let us take the fourth root of both sides. So we see that the fourth root, right, this is going to be 4 divided by 4. Let me write that out better, just so you guys can see it. We're going to do like this. The fourth root, that's equivalent to the fourth root, and 1/4. Now we're going to get here, we're going to get the fourth root of 16 is equivalent to 6. Let me do this in blue, just to be consistent. Green. 16 to the 1/4, because we can just, distribute that. E to the I theta naught plus 2 pi k divided by 4. So again, we're going to simplify this again one more time, and we're going to get that this is going to be, let me do that a little more room. Well, this becomes 2. E to the I, again, theta naught plus 2 pi k divided by 4. And we see our different values are not coming from the r, but coming from this changing of the theta by k amounts, right? Because this is a constant. This is a constant times some integer that's changing. So that's where we get our different values from, and let's solve for that. So we should get 4 values. So we're gonna get, I'm gonna do this, our theta, this part here, and our expression is what I'm doing. We're gonna get our theta 1 through 4, because we should get 4 different values, is equal to our theta naught plus 2 pi times k times n. And we know our k in this case is 0 through 3, because we have here, I just start again at 0 and then go up. So I'm going to pick my theta naught to be here, 2 pi around, right? And that's generally what you pick. If you pick, I'm sorry, my brain just froze. If you pick 0 should work, 2 pi it should work. Once you start going higher than that, you kind of get into this scenario where you're now saying it's the 5th root and 6th root. And I encourage you to think about why that's the case. But now let us solve for our numbers. And we're going to do this, and we're going to pick 2 pi. I generally like to start there. Plus, remember, you don't want to pick, for example, 4 pi. And then you have to be careful of your k values. I suggest just sticking with 2 pi when it's here. Anyways, plus 2 pi times 0 divided by 4. Right, our 4th root is n equals 4. And let's do this to our root value, which is equal to 4. We have our k's up there. And then we're going to get 2 pi plus 2 pi times 1 divided by 4. And then we get 2 pi plus 2 pi 2 divided by 4. And then we're going to get 2 pi plus 2 pi times 3 divided by 4. And then we, if you do this out, and you stick a calculator and think about it, pi over 2, pi 3 over 2 pi, and then the last value should be 2 pi. Again, and if you started at 0, you think what would happen? If we started at 0 for our theta naught, right? This was 0 instead of 2 pi. We get 0 divided by 4, which is 0, which means it's the same as 2 pi. Right? So that's just something to realize. And so we found these theta, our thetas, 1 through 4 is equal to this. So what we're going to do is we see that we're going to fill this in. So we're going to get that our values for this using kind of an extension of Euler's equation. Now let's stick it in this, right? Because this, right, this and this are our values for this expression above, this red expression. So we're going to get that Z1, Z2, Z3, and Z4 are equal to, we know that 2 is going to be the same. And the only thing that's changing is our angle. So this one is going to be pi over 2, pi, 3 over 2 pi, and then 2 pi. So let's graph these and see what we get. So I went ahead and I graphed the first one. So we're going to get 2, right, pi over 2, and then radius of 2. Second one is pi, right, so we're going to wrap around pi. And the radius is, again, 2. And then we're going to get, well, 2/3 pi is, let me start doing this in different colors. Let's do it in green. All the way over here. And this is going to be radius of 2. And then we're going to do the last one in blue, which is 2 pi, which is the same as just 0 theta. And that's 2. So now we can kind of geometrically see how we can express this as z. So we're going to do these all in blue. This is equal to, well, this first one's pi over 2. We have 0 real plus 2i, which is also equal to, some people are like this, where this is the real part, this is the imaginary part. Again, here we see that we get no imaginary, only real, and that's minus 2, right? It's minus 2 away from the origin. And then we get plus 0i. This can be written as minus 2 comma 0. Now I'm just going to do the rest, and I think you guys get the picture. Alright, thank you guys so much for watching. Hope you guys enjoyed this video.